In this video, we are going to see how to convert one flip-flop into another. So here I have taken the SR flip-flop. From SR flip-flop, we are going to convert it into JK flip-flop, SR to D and SR to T flip-flop. First, let us convert SR flip-flop to JK flip-flop. So the flip-flop basics like truth table, working, excitation table, everything is dealt in different videos, for which the link is given in the description. So now I will directly write the truth table and excitation table. So truth table of the new flip-flop, you take it, that is the JK flip-flop truth table is here. Now you write the excitation table for the source flip-flop. Here it is SR flip-flop. So excitation table is here. So if you see here, the main difference between JK and SR flip-flop is that in JK, J equal to K equal to 1. That is, both the inputs are 1, the output will toggle. Whereas in SR flip-flop, when both the inputs are 1, it is said to be a forbidden state, or we should not give S equal to R equal to 1 in SR flip-flop. Now with these two tables, we can convert the SR flip-flop into JK flip-flop. So excitation table is here, truth table, you include Qn also, J, K, Qn, Qn plus 1. Qn is the present output and Qn plus 1 is the next output. So for this combination, that is Qn and Qn plus 1, what is the value of S? You have to find in this excitation table. So first you take 0, 0. You find where is 0, 0 here. Here 1 is there and here. So for 0, 0, what is the S and R value? 0x. So write 0x, or don't care condition, 0x. Similarly, you have to fill up the remaining table. So next for 0, 1, you find where is 0, 1 here, here 1, 0, 1 and here. So what is the corresponding S and R values? 1, 0. So write 1, 0 here. Next 1, 0 condition. You find 1, 0 here and fill up the S and R values as 0, 1. So similarly for 1, 1, you can fill up X, 0. Now we have to find the relation between this JK and S. So draw the K map, take the present output Qn as 0 and 1, and JK values will have 4 combinations 0, 0, 0, 1, 1, 0, 1, 1. K map video is already available. You can click the link in the description to know about how to draw this K map. So first you take first 3 rows. Here J, K both are 0. So both are 0. If Qn is 0, what will be the S value? It is 0. So this S value is 0. Then if J and K both are 0 and Qn is 1, that is this position, 4th position, what is the S value? It is X. Like that you have to fill up the table. So next for 0, 1, here this green color you see, for 0, 1 condition, if Qn is 0, S value is 0. And for Qn is equal to 1 also, S value equal to 0. So here 0. Again for 1, 0 you can fill it. Next for 1, 0 we have to find. So for 1 0, that is this one, 1 0, if Qn is 0, S is 1. So here 1, next you will get X. Then for 1 1 condition, if Qn is 0, you will get 1 0. See here 1 0. So we have finished the K map, then we have to simplify it. So these two ones can be clubbed together. So what is the variable for this one? S is equal to, what is the common term here? J, and here the term is Qn bar. So J into Qn bar. So we got the relation between S and J. Now we have to plot the K map for R. Same procedure. You can fill up the table. Now ones are here. Now let us combine the ones together. So R equal to, what is the common term here? It is K, and here the term is Qn. So R equal to K into Qn. Now we have derived the relation for S and R. So take the SR flip-flop. What is S? J into Qn bar. So here multiplication is there, or dot product or AND gate. You need a AND gate to implement this function. So and put a AND gate here. J input is J is one input and another one is Qn bar. So Qn bar is here. So put a line from here to the other end. So this will be the input for S. For R you need K into Qn, another AND gate. K is the one input and the other one is Qn. So this is how you have to convert a SR flip-flop into JK flip-flop. Next we will see how to convert a SR flip-flop into D flip-flop. So we need to know about the truth table of D flip-flop and excitation table of SR flip-flop. So this is truth table and excitation table of SR flip-flop. Now we have to find for each combination what will be the SR value. So for Qn and Qn plus 1 0 0 condition, what will be there? 0x is the S and R values. So write 0x. For next combination 1 0, you see here 1 0, what should be S and R value? 0 1. So 0 1 is here. Next for 0 1 combination, you see 1 0 should be the S and R values. Simply have to check this combination here and write it there. Now we got this table. Let us draw the K map to get the relation between S and D. So draw the K map. So Qn can be 0 and 1. So D is the only input. So we have a 0 and 1. So now for both 0 0 combination, what should be S value? 0. For 0 1, it should be again 0. For 1 0, it should be 1, and again final one 1 1 condition, it is X. So X. So now this is a don't care. X means don't care. So you can combine these two together. So what is S is equal to? This is D. So S is equal to D. Next we can plot for R. Same procedure. So what is there for R? X 1 0 0. So these two can be clubbed together. So you will get here D equal to 0. So I can write R equal to D bar. So it is very easy. S is equal to D. So directly draw a line, and R is equal to D bar. So put a inverter and connect it to R. So this is how you have to convert a SR flip-flop into D flip-flop. So it is very easy. Just give the direct input to S and inverted input to R. Next we will convert SR flip-flop into T flip-flop, that is toggle flip-flop. Again you need the truth table for T flip-flop and excitation table for SR flip-flop. So for 0 0, for this combination of 0 0, what is the S and R value? 0x. So you can put 0x here. Then for 0 1 combination you have 1 0. So mark 1 0 here. Next for 1 1 combination x0 is here. So mark x0 here. Again for 1 0 it should be 0 1. So it should be 0 1 here. Now let us plot the K-map so that we will get the relation between S and T. So draw the K-map. So it is drawn between Qn and T because these two are the inputs. So write the S values 0, x, 1, 0. So this one cannot be clubbed with any one. So what is the value of this one? S is equal to, this is T and here we have Qn bar. Now again you draw the same thing for R. So you will get x0, 0, 1. Again 1 cannot be combined with anything. So R equal to, what is this value? T into this one Qn. So R equal to T into Qn. With these relations, let us draw the SR flip-flop. You see here, S is equal to T into Qn bar. It is similar to what we have done for JK flip-flop. So Qn bar is this line, T is here. Okay. So this is S. For R, you have T into Qn. If you need any help in this 3 variable K-map or 2 variable K-map or other flip-flops, please go through these videos so that you will get to know about the truth table and excitation table, how to write the excitation table. And apart from digital electronics, other subjects in electrical engineering is also covered in this channel. So finally, we will conclude what we have seen. To convert SR flip-flop to JK flip-flop, S is equal to JQn bar and R equal to KQn. For SR flip-flop to D flip-flop, S is equal to D and R equal to D bar. For SR to T flip-flop, same as JK flip-flop except that you will get T as the input. If you like the video, do subscribe to Read Electric Vehicle channel. Thank you.